Alright, so this is practical number 2 of lab 2. So right here we have our low-pass circuit that we already made for practical 1. The only thing that has changed is that we've actually taken out the motor and we put in a function generator to make a sinusoidal wave. So right here on channel 1 we have the voltage input, and then right here on channel 2 we have the voltage measured across the capacitor, so across the filter. So we go over here to the oscilloscope right here. We're also find amplitude. So we go to channel 1 and channel 2, and we go to measure, and then we find the peak-to-peak voltage. So to find the amplitude, we're simply going to get these, which you can't see right here. I have them written down. You're going to get these two values, going to divide them by 2, and then it'll give you your respective amplitudes. So you see this right here. I have it written down. Amplitude equals the peak-to-peak voltage divided by 2. So channel 1, the peak-to-peak voltage is 13.4 volts. Therefore, the amplitude of channel 1 is 6.7 volts. Same goes for channel 2. The peak-to-peak was 10.6 volts. Therefore, the channel 2 amplitude is 5.3 volts.
Okay, now in order to measure phase lag, all we have to do is take the cursor, and you see we can move this thing around. We have to make sure it's in terms of time. So what we do is we measure the time between 2 points. So first I'm going to choose the peak over here, which is at our input. Next up, I'm going to choose the cursor to go to the peak of our output. So from this, you can read over here the time difference, which is about 1 millisecond, or which is actually, it turns out to be closer to, let's see, we have, that's about 900 microseconds, which we used in this math. So we put into our formula, which is phase lag is equal to 2 pi frequency times the time difference, and that gives us about 0.728 radian phase lag, which, looking at our graph, looks to be about right. It's about pi fourths.
Thank you, Greg.